Hello, here's a little video to help you as you're wrapping up Unit 4, finishing that Active Chem homework number 9. So this short video is just going to be based on acids and bases. All right, so a question I'm noticing people struggling with is, why is calcium hydroxide a base? Well, first you need to recall that we've got two theories of acids and bases. So from Arrhenius's theory, we could say that it's a base because it has that hydroxide ion. From Bronsted-Lowry, we could say it's a base because it's going to be able to accept a hydrogen ion. When that calcium hydroxide is dissolved in solution, it's going to make calcium ions and hydroxide ions, and it's actually going to make two hydroxide ions, so it could accept a lot of hydrogen ions. You've also got to be able to take a look at neutralization reactions and figure out what's the acid base and what's the conjugates for those acids and bases. So if you take a look at this, see if you can figure it out. All right, so how'd you do? First thing I'm looking for is, okay, what's donating a hydrogen ion? Because Bronsted-Lowry and Arrhenius both agree on that. So as I'm looking at that, I'm like, that water is donating a hydrogen ion. It's becoming OH minus. CH3O minus is accepting a hydrogen ion. And Bronsted-Lowry says that anything that accepts a hydrogen ion is a base. So that's what allows me to figure out, okay, CH3O is our base, H2O is our acid, and our conjugates on the other side. So what's left of that base is our conjugate acid. Notice that that conjugate acid, CH3OH, can also donate a hydrogen ion. All right, so if we give you an acid, can you figure out what the conjugate base would be if it was in a neutralization reaction? So let's take a look at this first one, hydrochloric acid. What would be the conjugate? And I'll show you those in a second. This is one from the homework. H2AsO4 minus, what would be its conjugate? So hopefully for HCl, you got just the chloride ion. And for H2AsO4, hopefully you got HAsO4 2 minus. Again, as it's donating that hydrogen ion. When we're looking at conjugates, that's our Bronsted-Lowry definition. Okay, here's a quick question for you. Those hydrogen ions, if they were to increase by a factor of 10, what happens to our pH? Hopefully you're thinking pH is going to decrease by 1. The lower the pH, the more hydrogen ions, the more acidic. What happens if our hydrogen ions were to decrease by 10,000? What would happen to our pH? Hopefully you were thinking that our pH would increase by a factor of 4. Since our hydrogen ions are decreasing, our pH is increasing. It's becoming more basic or neutral, depends how acidic it was to start with. And remember, this happens because the pH is a logarithmic scale. And so every increase in hydrogen ions, a factor of 10 increase of hydrogen ions affects pH by a factor of 1. All right, a couple formulas. You definitely need to know these formulas. Please make sure that you memorize them because you're going to need to use them a lot and keep them in mind. All right, so if that's your pH, what's your POH? Well, yeah, it's really that simple. All you've got to do is think pH plus POH is 14 and simply subtract to get that your POH is 3.85. So again, just keep those formulas in mind. If you are given the pH and asked to find the hydrogen ion or hydronium ion concentration, this last formula is the one that you want to use for that. And here we're asked it right here. So see if you can figure out that hydrogen ion concentration. So again, just using the formula and just substituting in. This is one place in chemistry where you can use the caret. or there's an e to the a second function button that I showed on the calculator the other day that you may want to take a look at. And so there is our hydrogen ion concentration, rounded to 3 significant figures, so I put it in scientific notation. Here's another question for you. What if your pOH is 9, or 1.9, excuse me? What kind of solution? Well, for me, I've got to figure out the pH, because pOH doesn't really tell me, so simply do that subtraction. And I find out that my pH is 12.1, so it's a very basic solution. I could then go on and figure out what's my hydrogen ion concentration, what's my hydroxide ion concentration from there. Now, if we have an acid and a base reacting in a neutralization reaction, of course our products are salt and water, but in this reaction, we have phosphoric acid reacting with sodium hydroxide. Sodium hydroxide is the base that you use in the lab. And oftentimes, your first thought may be, okay, so I've got this problem like this. I'm going to use M1V1 like I used in the lab. The only problem is you cannot use M1V1 equals M2V2. Because phosphoric acid is what we call a triprotic acid. It has 3 hydrogen ions to donate. And so for this one, you will have to write out the equation. And hopefully you can see that up there. There we go. So as you're trying to solve this equation, you're going to need to write out a balanced chemical equation. And as you're doing that, you're going to need to add those coefficients. So we're trying to find the concentration of the phosphoric acid. We know the concentration of the NaOH. Now I do have a typo there in my products. It should be 3 NaPO4 or Na3PO4 for that product. But we don't really need to worry about that here because we're really just looking at the acid and the base. What's the concentration of that acid? And so but we know about the base, so we're going to need to use that base and what we know about it to figure out the number of moles of the base. And so we're going to do that using that molarity equation. Remember, when you're using that molarity equation, you've got to convert to liters. So once I figure out my number of moles of NaOH, I can look at my mole ratio for my balanced equation, 1 to 3, and figure out my number of moles of phosphoric acid. My moles of phosphoric acid divided by my volume of phosphoric acid in liters is going to give me my concentration of H3PO4. And so you can see that there, rounded to 3 significant figures. So it's acid-base reaction with a little bit of stoichiometry in there. So I hope this helps you as you wrap up homework number 9 and studying for the Unit 4 test.